Okay, let's go ahead and get started. So, last time we were talking about linear equations and how they can relate to functions. And that one thing that is helpful with these linear equations is to graph them. Because basically, graphing them will give us an idea of what their behavior is like overall. In other words, as we plug in different numbers for x, what does this thing do and spit out for y? So there's several different ways of tackling these ideas. For instance, like we said last time, we can put this linear equation into standard form, which would have something like, x plus y equals whatever constants we might have. So I'll say c. Okay. Now, this is perfectly fine. However, there is another way that we can look at these, and that is not in standard form, but in what we call slope-intercept form. So that would be y equals m x plus b, which you've probably seen before. This is a very common idea in mathematics when we're dealing with functions and graphs and linear equations. And the reason that it's so common for you to see this is because this is a form to put the function into, or the linear equation into, that basically spells out everything for us. So again, we have y over here on this side, and y is the thing that is going to be spit out by our machine. It's whatever product the machine produces. And mx plus b is all of the mechanics of the machine, like we talked about last time. So if we plug in a number for x, whatever input we put into our machine, then m and b are going to process it. Again, they're the parts of the machine, and then spit out a y. Now, the nice thing about it being in this form is because m and b tell us two very important things. So m, if I just, whoops, I need to change back to defaults. So m this is our slope. Increase the size of that a little bit so you can see it better. Okay. So again, m is our slope. And slope is the idea of, how much is this thing changing from point to point. So when we plug in an x, how much does it change from one value of x to the next? Okay? Then we have b, which is another very important... Oh my goodness, why is it doing that? It's a very important piece of our equation here. And that is the y-intercept. Okay, so the y-intercept is where our graph, our line, is going to cross the y-axis. So it'll cross somewhere along here. We just don't know where. However, if we look at the b part of our formula, of our equation, then it will tell us where that's going to cross. So for instance, if b were -3, then our line is going to cross here at -3 at some point. Let's see, what did I just get? Never mind. All right. So let's take a look at some linear equations that are in this form. I'll give us a random one. Something like y equals, how about 2x plus 4. Okay. So, again, if we look at this, we have two things that will tell us a lot about our graph, and that is the slope and the y-intercept. So the number that is in front of x is, if we look back at our form here, m, and m is the slope. So here we have a slope of 2. Okay. Well, what does that really mean? Well, you have to think of slope as being really two values. So we have 2 right here. Anytime that you're looking at a slope, thinking about it as a fraction instead of just a normal integer. So if we have 2, 2 as a fraction is 2 over 1. So the top part is how much the y is changing. The bottom part is how much the x is changing. So another way of saying that is how much are we going up versus how much are we going to the side. So this says from one point to the next, we will go up 2 and then over to the right 1. So you probably have heard of rise over run. That's where we get this from, is because the up and down motion comes from the top number, and the left to right motion goes from the bottom number. Now, I always think about the bottom number as being a right motion, and the top number will tell us whether we go up or down, whether it's negative or positive. Positive means it goes up, negative means it goes down. Then this number right here, 4, tells us that our line, our graph, is going to cross at the point 4 somewhere on our y. So that'd be right here. And that actually means that we can go ahead and graph this without having to plug in any values or anything. We can just look at the y-intercept and the slope and make a graph. So I'll do that real quick. So again, we know we have a point at the y-intercept, which is 4. We can go ahead and plug that point in here. Okay. And then where do we go from there? Well, we look at our slope. Our slope, again, tells us how much we change from one point to the next point. So this is telling us that we need to go from here up to and over to the right 1. So I will go up 1, 2, and over to the right 1. Here's my next point. Again, I can go from here, since the slope isn't going to change any, I can go from here and use the same slope to go up 2 and over to the right 1. Up 2 and over to the right 1. Up 2 and over to the right 1. And we can plug in as many points as we want. However, 3 is typically all you need to make a line. So I've got definitely more than 3 here. I can make my line. So I'm going to go ahead and put my line in here. That looks pretty good. And there's my graph. Okay, so again, slope-intercept form is actually pretty useful for just graphing this thing. It shows us the y-intercept and the slope, and both of those things are very important for finding points on our graph. Standard form is a little bit more suited for other uses. Okay. Let me try another one here for us. So I'll just back this up. How about y equals negative 2/3 x plus 8. Okay. So, same idea here. We still have a y-intercept and we still have a slope. But this time our slope is already as a fraction, which is nice, but it's also negative. So remember, what that means is instead of going up 2 and over to the right 3, we're going to go down 2 and over to the right 3. Again, I always like to think about it as going to the right for whatever number's on the bottom. So, first things first, we need to look at our y-intercept. That will give us our first point because that tells us where the graph crosses this line, this y-axis. So I'm going to put a point at 8. There we go. So now I need to look at my slope to find the rest of my points. And again, this is negative 2/3. So because it is negative, it's telling me that I'm going to go down 2 and over to the right 3. So from this first point that we found, we go down 2, 1, 2, and over to the right, 1, 2, 3. So we've got a point here. Again, we go down 2, over to the right, 1, 2, 3. We have another point here. Down 1, 2, over to the right, 1, 2, 3. We have another point here. Okay. And from this, we can then just connect our dots and find our line. So, let's see. 1, 2, 3, yeah. Our line is going to extend like that. Let's try that again. Our line is going to extend like this. And there's our graph. So knowing that slope and knowing that y-intercept can be quite useful. And I will go ahead and pause for any questions we may have. Okay, I'm not seeing any questions, so I will move on. And let's see. I'll come back to this graph in just a minute, but there's something else that I want to show you before we come back to it. Okay, so in the real world, when we're dealing with these kind of things and we're doing some kind of analysis on data, maybe we are looking at, I don't know, migration, e-migration of animals in the wild, okay, or maybe temperature versus pressure, something like that. We won't have a nice formula to go off of. Instead, what we're going to be doing is we're going to be looking at data points. So, given a certain temperature, what is the pressure? And we'll collect this data over time, and then we'll try to graph that on a graph. So, can we get a formula to predict what the future points will look like? Yes. That's actually very doable. One thing that's important for that, though, is to find the slope of that line. Okay? So, let's say that we're just given 2 points. I'll just come up with 2 real quick. 2, 5, and maybe -3, whoops, 1. Okay, so we're just given 2 points, nothing else. Okay, so what we can do to find the slope here is use the slope formula. So the slope formula goes like this. Slope m equals y2 minus y1 divided by x2 minus x1. Basically, what this formula is saying is y2 minus y1, that is how much is this changing? How much do our numbers change from the second y to the first y? Same thing with the x's. How much is the x changing? And then it's divided, because again, if we think about it, it's rise over run. Okay, so the first thing we need to do is designate which one of these is our first point and which one of these is our second point. And it does not matter which one we call our first point and which one we call our second point, just as long as we keep it straight from then on forward. So I'm going to say that this is our first point, which means that this right here is our first x. This is x1. And this is our y1. That means that this is our x2. Oops. And this is our y2. Okay. So now all we need to do is plug these points into our formula and then get our answer for our slope. So, again, it's y2 minus y1 over x2 minus x1. So y2 is 1 minus our y1, which is 5. And that's over x2, which is -3, minus x1, which is 2. Okay, and again, this is slope, so m. All right, so we just need to look at the tops and bottoms separately. So 1 minus 5 is -4. And then negative 3 minus another 2 is negative 5. Then remember that a negative divided by a negative would be a positive. So this actually comes out to be positive 4 over 5. And there's our slope. So, with a little bit of extra stuff, which I'll get into later, we could then use this to find our equation. Okay? You know what? Actually, why not? Let's go ahead and find the equation. It's easy enough to do, and we have the time. So to find the equation, we actually have another formula that we can use. And it goes like this. Let's see. Oops, my pen's the wrong way around. Y minus y1 equals m times x minus x1. Okay, so again, pretty simple. Why not show it? So again, this takes a point. This is called point slope right here. And it says we just need one point and the slope, because again, if we have the slope and we have a point, we can figure out where the rest of the points are from there. We just take that point, say, all right, our slope is, in this case, 4 over 5, so go up 4 over the right 5, and it finds the rest of it for us. So this will actually give us the equation of our line. So all we need to do is plug things in. So I'll go ahead and do that. Now y and x are the generic y and x, like we have here, y and x. So they're not going to change. We don't need to plug anything in for y and x. They're just going to stay like that. It's only y1 and x1 that we're going to plug things in for, and of course m. So if we plug things in, this would be y minus y1, which is 5. Whoops. And then it's equal to m, which is 4 over 5, times x, again, it's just the generic x, minus x1, which is 2. Okay, so now we need to simplify and then get y by itself. So simplify and solve. Well, to simplify, again, we would like to get rid of these parentheses. We want to distribute this number into here. So we're going to distribute 4/5 into the set of parentheses. So now we have y minus 5 equals 4/5 x minus, let's see, 4/5 times negative 2, that's going to be 8/5. Okay. Now, again, we need to get y by itself to solve this thing, so we're going to add 5 to both sides. Well, we need to do negative 8/5 plus 5, so let's see here. 5 over 1, make that 5 over 5. That'd be 25. So 25 minus 8. Okay. It's going to give us 17 over 5. So y equals 4/5 x plus 17 over 5. So we now have it in y equals mx plus b form. Again, slope-intercept form. So our slope, like we said, is 4 over 5. And our y-intercept is at 17 over 5, which isn't an exact point, but we can still graph that. So I'll pause here for any questions we may have. Okay, I am not seeing any questions, so I'll move on. But before I do, these two formulas that I have highlighted in green here are very important, and you should write them down in your notes somewhere because we'll be coming back to them quite a lot. And they're very useful in general when we're looking at any kind of graph. Okay, so I'm going to go back up here. Nope. Let me check this real quick. All right, very good. Good to have you with us, Victor. All right. So, like I said, we were going to come back up here to see something else. And that something else is sort of an interesting case. What if we had y equals something like 3? Just 3. No x. So no slope, just 3. what does this look like? Well, if that is the case, then the points for this graph are going to be just anywhere that we have 3 for our y. So, yeah, we got a point here. But every other place that y is 3 is also a point. So this is also y is 3. This is also y is 3. Everything over here, this is y is 3. This is y is 3. All of these points along this line right here are y is 3. So our graph ends up being something that looks like this. Just a line right here that goes through all those points. Okay, so we got a line that goes right through those points, a horizontal line. Okay, so what does that mean about our slope then? Because that's very strange. It's not changing really from point to point, is it? It's a flat line. So do we have a slope? Well, this is a question for our slope formula. So let's come back down here and take a look at that. And I'm going to erase this stuff. I'm going to keep this, though, because we're going to use it. Okay, so let's just take 2 random points from here. Let's say -2, 3, and 1, 3. Doesn't matter what points we choose, any of them will work. So again, we're going to choose -2, 3. And our second point was 1, 3. So again, if we looked at our graph here, which is actually kind of hard to see, I'll try to select that. Yeah. And let's make that something that stands out. Cool. So if we look at our graph here, it is just a flat line. And what does that mean about our slope? So I'll designate this one our first point and this one our second point. So that would mean that this is our x1, this is our y1, this is our x2, and this is our y2. So we need to plug these points into our formula here. Okay, so m equals, let's see, y2 is 3. Then y1 is also 3. x2 is 1. x1 is -2. Okay, so let's see what we get here. Well, 3 minus 3 is 0, so top part will be 0. And then the bottom part here, 1 minus -2, minus negative means plus, so 1 plus 2 is 3. Alright, well we can simplify this fraction here because 0 divided by anything will be 0. Which means that our m slope is 0. Okay, so we can actually modify this a little bit then and say that since our slope is 0, this is really y equals 0x plus 3. Because, of course, if we have 0x, 0 times x is 0, 0 plus 3 doesn't make any difference, so we don't really need 0x in here. All we need is y equals 3. So our y-intercept is 3, which makes sense, yeah. Our y-intercept is indeed 3, and our slope is 0, which also makes sense because we aren't going anywhere. We're not going up any. We can go over 3, sure, we can go over 1, we can go over however many we want, but we're not going to be going up anything. So our slope is 0 over any number. It's just 0. Okay, so that's what we would say for this line. We have a slope of 0 here. Okay. So this is one interesting case. Again, if we just have y equals something, if there's no x in here at all, then that means that our slope is 0. And it's because that slope is 0 that we don't have an x. That 0 is canceling out that x and getting rid of it. Okay, so that's interesting. Let's take a look at another one. So back this up a little bit. All right. So instead of having y equals 3, what if we had x equals something? Oh, and I guess I'll have to take all that out again. Okay, so what if we just had x equals something instead of y equals something? So x equals, same thing, 3. That's easy enough to graph, just like before. This, instead of being, y, could be all the things along this line here. That means that x could be all the things along this line. So anywhere that x is 3 is going to work for us. So we have a point here. We also have a point here. Have a point here. Just anywhere along this line, it does not matter. I can put a point there. I can put a point here. Again, it does not matter where I'm putting points as long as they are somewhere that x is 3, which is all along this vertical line here. So I'll go ahead and put my line in now. And I'll make it nice and clear for us. And so there's our graph. Whoops. Woo. Alright. So instead of having a horizontal line like we did with y equals 3, like right here, we have a vertical line. Okay, so does that mean we have a whole lot of slope, or does it mean we don't have a slope? Again, it's not really changing, it's just going straight up. Well, to figure that out, let's go back to our slope formula. So we'll need to choose 2 of these points. I'll choose 3, 2 and 3, 6. So the first point is 3, 2. And the second point is 3, 6. Alright. So, again, we need to say which one is the first point and which one is the second point, and it does not matter which one is which. We just have to say which one is which. So I'm going to say that this is the first point, which means this will be my x1. This will be my y1. This will be my x2. This will be my y2. Okay. So we just need to plug these into our formula to find out what this slope is. And it's going to be something weird, so hold on. So, m equals, woo, let's try that again, equals y2, which is 6, minus y1, which is 2, over x2, which is 3, minus x1, which is also 3. So 6 minus 2, that's going to give us 4. And then 3 minus 3 is 0, and that is a problem. Like we have said in the past, we cannot divide by 0. So if we have 4 over 0, that means 4 divided by 0. And in algebra, at least, that means that this is undefined. So our slope here, m, is undefined. So, here, if we have a line that keeps going straight up and down, no changes left to right, it means that we kind of don't have a slope. It's undefined. It's just this weird value. And this gets to something kind of new. And that is the idea of something being a function or not a function. So a function works perfectly fine everywhere. Nothing to worry about. You don't have any strange cases where you have undefined values like this. So a function passes what is called the vertical line test. If there's a vertical line somewhere in that function, then it is not actually a function because it has some place that it breaks. If we don't have any vertical lines like this, then that thing is indeed a function. It's perfectly fine and works everywhere. And that works not just with linear equations like we're doing right now, but curvilinear equations and other things like that. So, if you ever see a completely straight up and down vertical line somewhere in your graph for a function, it's not actually a function. So I'll go ahead and I'll pause real quick for any questions we may have. Okay, I don't see any questions. So, things to keep in mind. First of all, y equals mx plus b. This is our slope-intercept form, and it's called that because it shows us explicitly our slope and our y-intercept. This right here is our slope formula. Again, it will allow us to find the slope of a line given any 2 points on that line. And if we want to use it, we have to define which point is the first one and which one is the second one. It does not matter which one we choose to be the first one and which one we choose to be the second one, just as long as we keep it straight when we start putting things into that formula. And the next one, I'll go ahead and make it green again, is our point slope form, which is y minus y1, again one of these points here, equals m, our slope, times x minus x1. Which, if we have a point and a slope, then we can plug those two things in for our point, y1 and x1, and our slope, m, and it will give us the slope-intercept form once we solve things for y. So, all three of these are very important to keep in mind. So again, that's the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept, which is where the graph crosses the y-axis. Slope formula, given 2 points, we can find the slope and use that slope to find the rest of the points on the line. And using point slope, we can find our equation given just a point and a slope. So if we're just given 2 points, we can actually find our formula for our line. And that formula is very helpful for finding the rest of the points on our graph. Okay. So I think that will do it for today. We will continue on with functions next time on Friday. And plan on having a quiz on Friday as well. Short one, simple one, easy one. Just I want to make sure that everybody is getting this down, so keep that in mind. And I'll talk more about that on Friday. But for now, that's all I have for you. I hope you have a great day, and I will see you on Friday. Have a good one.